Now the first one over here, can you guys see it's a little bit small? I couldn't put it on my iPad, so we're trying to sketch the curve with this even vector equation and indicate with arrow the direction in which t increase. Okay, so I'm going to make it larger. So what was the vector equation over here? It has, maybe remind you. It is what? T squared minus 9. That's a t, right? Okay, that was this is the vector equation. This vector equation, the output is the vector, right? But what in 2D or 3D, the vector? 2, okay? Only 2 components, okay? In 2D. So this will be on, so this will be just x, and this will be the y, right? Now to find this, to find this, sketch the curve, then you can eliminate the parameter t, right? So how do you eliminate the parameter t? Because t is y, can we just substitute t by y over here? Okay. So if we substitute the t here by y, what kind of equation do we get? We have what? X is t squared minus 9, but then the t here is replaced by y, so we have what? Y squared minus 9. What is that equation? X equal to y squared minus 9. What kind of curve is that? It's a parabola. Open which way? Open to the right, right? And then the vertex will be, the vertex is when y equal to 0, so x is negative, negative 9. See, when y equal to 0, x is equal to negative 9. So we'll be over here. So we'll be over here negative 9, and then open to the right. The reason that open to the right is because the positive coefficient on the y square. So x equal to y square goes this way, and then if you have x equal to negative y square, it goes this way. Okay? So it goes like this, and then you want to indicate the direction it moves as t increase. So as t increase, which way it moves? This way or that way? I'm not sure right now. Let's think about it. Which way? So as t increase, as the y here increase, what happened to the x? As the y increase, so shouldn't be this way? Yes, that's this way, not the other way. Okay, so it goes like this. So as the t increase, as the y increase, then it's going to chase out this. It's going to go like that. So the answer here will be this. Okay, this way will be like that. Okay, so that was the first one. So one way to do that is eliminate the parameter. Okay, let's look at the second one. Oh, I'm going to make it larger so you can see better. So RT is equal to T, 2 minus T, and 2T. Now, my question over here is, which point does this one go to? This application. Does it ring a bell? This right? Does this one remind you this 3 component over here? Does it remind you the equation for what? Yeah, it's very magic. But equation for a 9, right? A 9. And so this one over here, I've been here. It's a 9 that goes to which one with which direction vector? You're looking at this. How do you write the 9 over here? Do you remember the one here? R is equal to what? R naught plus what? T times V. Yes, you got it. Okay. Plus TV. Right? This is for the 9. Okay. And this is for the 9 that passed through this R naught and has this direction vector. V. So that will be this. Okay. So that will be the 9 over here. So pass through R naught and has the direction V. That's this. Okay. So this one kind of remind you that. Okay. So looking at this, we also remember the scalar trigonometric equation. Yeah, no right trigonometric equation. So the scalar trigonometric equation for this one over here, it is what? For that one, this is for the vector equation for 9. Right? And then we also have the parametric or we call it equations for 9. Okay. What was it? X equal to what? X not, oh yeah. X not what? Plus AT, yes, AT. Then the Y is Y not plus ET, and then D not plus CT. Where ABC here are the vector, the component for the vector B, right? This one here, does it remind you that? Yeah. So comparing this one with this one, can you tell me what is X naught? So this one here is actually basically it is X naught plus AT, right? This is Y naught plus BT. This is D naught plus CT. So from here you know that it passing through which point. So what is X? So what is that point? So that will be 0, right? And what will be Y naught? The 2, right? And so 2. And then what about D naught? 0. Yes. So we know that it can't do this point right here, right? Now let's figure out the direction vector. What's the direction vector? That will be what? The coefficient for the t, right? So that will be 1 and then what? Negative 1 and then 2. So that will be 1, negative 1 and 2. So that will be a 9 that pass through this point and has this direction vector. But how do we draw it? How do we draw it? Now to draw this, you can draw the coordinate. So X, the Y, and then Z. Okay. So we're going to locate this point first. 0 to 0. Okay. So we're going to go 0, 2, 0. So say this one is 2 on the y-axis. So that's the point 0, 2, 0. Okay. Okay. Now it's going to have this direction over here to be 1, negative 1, 2. Okay. So 1, negative 1, 2. So what does it mean? That means, so if the vector starting at the origin is going to go 1 unit in the x direction, and then negative 1 unit in the y direction, and then 2 units at the z direction. But since we started over here, then we're going to have that direction over here. So you're going to move this 1 unit. So starting from this point, move to the positive x-axis 1 unit. So we're going to go, let me use a different color. So we're going to go positive x-axis, so this way. So we're going to go 1 unit. Okay. And then this is negative 1. So which way I move? To the negative y direction, right? So which way? This way or this way? This way, yeah. So we're going to move negative 1. So negative 1 right here. So this way. Okay. And then finally, it is positive 2. So which way I move? We go up. Okay, so we go up 2 units. So 1 and 2. If you end up with your point over here, go up 2. So that space curve is this line over here, passing this point and this point. So you can actually get this without using any mapping device. You try to think about it. So you get the point, and then you also get the direction vector. Okay. So get the point, the direction factor is from this one, which way you move? Move one x direction, negative one in the y direction, positive 2 in the z direction. You got the 2 point, you can draw the space curve. Next one over here. Okay, this is, as you can see, is one of the whole problem. Okay, so we're going to draw the projection. Oh, how to see? We draw the projection on this curve on the 3 coordinate plane and use projection to have sketch the curve. Okay, I'm going to make it larger so that you can see better. And it's multiple choice. How many times you can submit for each problem? 5 times, right? Multiple choice. There's even sometimes less than 5 choices. So you should get it right. But it's better that you understand it, right? So let's make this one larger. You can see better. So we have what? RT equal to T sin T and 2 cosine T. Okay? So which one you think it is? We have 1, 2, 3, 4, A, B, C, D. Which one you think is the one? Okay, you think it's C. Can you give me some reason?
It's kind of similar to if you mix this one on the x-axis instead.
Oh. Oh. Yes, that is a similarity. So Shannon noticed that kind of look like this way. That except the D equal to T, this one here is X equal to T. Kind of like that. So it's kind of like a spiral, right? And then a spiral, and then but in the X direction, instead of on the Z direction. That's very good reasoning. However, this one is also, isn't it? Isn't it this also is spiral on the X direction, right? This one or that one?
I did think this was a 2 percent multiplied by 2.
Yeah. Okay, let's think about it. So what do you have here? So we do have this T sin T, 2 cosine T. Now, whenever you see sine and cosine, if you don't recognize it, it kind of relate to that here, right? So maybe we can try to isolate the sine and cosine. Use of this sine square, right? Plus cosine square equal to 1. So this is the x, this is the y, and this is the z. Okay, so that means this one here is y square with cosine t. Cosine t is what? D over 2, right? D over 2. So that means it's d over 2 square equal to 1. Okay, does this ring a bell? What kind of corner section is this one? It is an ellipse, right? Good job. Okay. So it is an ellipse. How does it look like? So if this is y, and this is the z, the ellipse is going to have do we call it the arm or this? What number should I put along this x? Along the y? Yeah, it's 1, right? So it is 1. Okay, 1. And then what about here? That will be 2 and then -2, right? So the ellipse looks like this way. Yeah, the ellipse looks like this way. So it's going to have this from here to here will be 2. Okay, so it's going to be an ellipse. So that one, so we know that when you project to the YG plane, it's going to be an ellipse. Okay, it's always an ellipse. Okay, so when you project, think about remember the YG plane? So this side here is the YG plane. The floor is XY plane. That part here is XZ plane. The YG plane, imagine, is this Y ball here. So when you look over here, you always see ellipse. When you look this way, looks like this too is you can eliminate because on the YG plane it doesn't look like this. But this too, they do look like it, right? When you look at it. But which one? B or B? Sure? Why?
Y'all listen to.
Shannon, you say sure.
Oh, I changed my answer. I didn't see that. I just don't know.
Okay. Okay, good. You finally got it. This one here, the Y, the Z goes to 2. This one here, looks like the Z goes to 4. Yeah. So it's this one. So the answer here is this one. Okay. So it goes to 2 right here. Okay, from here to here. So and it is going to be ellipse. So when you project to the right, you think it's going to be ellipse. And then when the t increase, the x increase. So the x is going to, so when the t increase, the x increase. So it's going to be 5 so. So this time it's going to be ellipse. So imagine the ellipse go this way, and then as the t increase, it goes to the positive x direction, right? Okay, so imagine this coming out of the screen. Okay, well, good job. Okay, next one. Okay, I want you to match this with the correct graph here. Oh, by the way, someone asked me in the quiz, why is the Earth a project surface? Why is the Earth a project surface? Example of project surface. What kind of project surface? It is the ellipsoid, right? Ellipsoid is part of the project surface. Yeah. So it's on there. Ellipsoid and sphere. Sphere is actually a special case of ellipsoid. So Earth itself is an example of a project surface. Okay, take a look here. Which one? Maybe this is too small. I can make it bigger. So let me write it bigger. So we have x equal to t cosine t, y equal to t, z equal to t sine t, right? Okay, and then t greater equal to 0. So what do you think?
That one.
Okay, A, B, C, T. Huh? B? B? Oh, good job. B is correct. What's your B is correct. All right, what's the reasoning?
I mean, it's yeah, but it's times t.
Okay. So so your reasoning is but it's not a helix. The helix is like but kind of like it, right? It's not a spiral. But then the t here is t increase at that increase, right? So another way to do that is I also can think about this way, right? You have sine t cosine t. We can also make use of the identity. So cosine t, cosine t is going to be x over t, right? And then sine t is z over t. So therefore, x squared over t squared plus z. Actually, we can just square both. We can just go ahead and square x squared plus y squared, and what do we get? X squared plus y squared is equal to what? T squared. T squared, right? It's t squared times because we get cosine squared plus sine squared. But then this part here is 1. Yeah, you're right. This part here is 1. So you will just get x squared plus y squared equal to t squared. And that look like it's the equation for a circle, right? It's a circle with this xy plane. It's a circle with radius to be t. Yeah.
The z instead of y.
Oh, yeah, Melanie, thank you. That's D. Okay. Good job. Yes, pay attention, participation too. Okay, that's great. So x squared plus, okay, so this is D. That is D. The equal t squared. So it's going to be a circle, but then with the t as the radius, right? But then as the t increase, so you're going to see circle when you're going to when you look at the FG plane. So imagine that wall there is an FG plane. So look that way, you should see circle. This one here, if you look that way, is it all circle? Okay, they're all circle. But then as the t increase, okay, as the y here increase, as the y increase, what happens to the circle? The radius of the circle also increase, right? So as the y increase, the radius of the circle also increase. It goes like this. So bigger and bigger circle as the y increase, right? And because t is greater equal to 0, we only get like this part right here. Y is greater equal to 0. Okay? Otherwise, you will get, if t is all real number, then you could actually go the other side, another cone. And that also reminds us of the general formula for cone. Okay, this is for the cone, the equation. And that actually fit into, we can actually turn that into this standard equation for cone like that. Okay, so you guys did a good reasoning. Okay, good job. All right. Okay, next one. Okay, can do this. Hey, tell me, what do you think? Okay, again, we see this sine and cosine. So how about we square the x and y and sum them up? Okay, let's see what we get. So from this, x squared plus y squared is equal to what? Equal to, yeah, which is 1, right? It's equal to 1. Okay, so that means that when you look at the xy, the floor, think about the floor as the xy plane. So when you project the curve down onto the xy plane, you're going to see this circle. So x and y and z. So when you look from above to look down, always have this circle. X squared plus y squared equal to 1. So when you look down, always like that. So which one? Could that be this one? No. This one? No. This one? No. This one? Yeah. Okay. So that one. But how about but then what about this one? This one or that one? So when you look down to that, it's a circle. But what happened to this? So as t here increase, what happened to z? Z is going to increase, but increase in what kind of rate? Exponentially, right? Exponentially. So they make faster and faster, right? So, and then keep on going, right? Then, do you think this one works? This one looks like it goes down and it stops, right? This one doesn't. But this one works. So, as the t increase, the z is going to increase exponentially. So, faster and faster is going up. So, it will be different. So, imagine it's kind of like a string, right? Stretch it. So, that's the one. Okay? Very good job. All right. So that the curve with this line on the cone, how do you show this? Now remember this type of problem when you do proof, you can actually put anything and still get credit. But it's good that you know how to prove. That's why I put this kind of problem there. Just for your benefit, you get the credit anyway. Okay, how do you prove this? You just plug it in, right? So you can just plug in x squared and the y squared. And then it turned out to be t squared, but then t is equal to z, so that's equal to g squared. So it's going to lie on this cone. Remember, this is actually, it fit in the general formula for cone. Remember, right? So we just did that before. So for the cone, right here, this one, this is for the cone, okay? So z equal to, that's for the cone. This is actually, when you look at this, that's the line in the cone. So that was only a one-line proof, okay? So not too hard. Okay, the next one, okay, I'm going to ask someone who's in front of this leader to the class. What about Alex?
If two objects travel through space along two different curves, it's often important to know whether they can collide. Will this allow him to moving particle to their collide? The curves might intersect, so we need to know whether the objects are in the same position at the same time. Suppose the trajectory of two particles are given by the vector function. Particle 1 is equal to p squared 9t minus 4t squared. So 2 is equal to 11t minus 48 t squared and 12t minus 35 squared. T is greater than or equal to 0. Find the values of t at which the particle flies.
Okay, perfect. Okay. So I'm going to write that down. So that was t squared. Okay, what's the second one? 9t minus 14. Okay, and the last one? See, you guys help me. T squared. Okay, and then you have the second one is 11t minus 28. Okay, and then the last one, t squared. The last one, 12t minus 35. Okay, so so when the two curve over here, two space curve collide, okay, so it's going to intersect. So when they collide, then that means what? What does it mean? So this is R1 T, and then maybe has some space curve, something like that. And then R2 T is going to be from where? Okay, this. And then maybe have a space curve like that. And then when they collide, what happens? How do you find intersection? Intersection is the one that when they collide, that at that T, at that certain time T, they actually hit each other, right? Collide. Okay. So maybe at this point, at this T, they're going to end up at the same position over here. Okay, which means that R1 and R2 is going to equal at that time. But then how do we find that time T then? How do you find intersection? Do you guys remember? You set them equal and then solve for T, right? So we're going to set them equal and solve for T. So this one equal to this, okay? So we have T squared equal to 11T minus 28. What else we can set? We're going to set. We're going to set this equal to this, right? 19 minus 14 equal to T squared. And finally, this equal to this. Okay, let's try this. It's kind of like algebra, right? So this is T squared minus 11T plus 28 equal to 0. Solving this, T equal to what? Isn't it 4 and 7? 4 and 7, right? 4 or 7, right? Okay, what about this one? T squared minus should be positive. Why? Because this one factor into what? T minus 4 times what? T minus 7. So for this to be equal to 0, T has to be equal to 4, right? It has to be positive. Okay. Okay, now what about this one? Huh? So T will be equal to, this one I factor into -2, -7, 2 and 7, right? Okay, you get 2 and 7. So you will get 2 or 7, okay? What about the last one? 7 and 5, yes, 5 or 7, okay? So for all of them to equal each other, each component equal to each other, then you end up at the same point, right? Then they connect, right? So in order to satisfy this, all three components, right? All those equations, what does T equal to? 7. Yes, you got it. So the answer here is T equal to 7. 7 is the only one that make all of them work. Okay? Okay. Now that's the end of our lesson.